we now start trimming on the outer claw.
Is that blood under there?
No, that's normal black hoof pigment.
Got it.
The white line's starting to reappear. Morning, Wendy.
Morning,
Dave.
Roger.
Morning, Roger.
Lovely morning.
Beautiful.
How many have you got today, then?
There's only 8 today, Roger.
8. All right. Is that trims or lames or a bit of both?
A bit of both, Roger, today.
Thank you. All in there and ready. A bit overgrown on the outside there, she is. There you go. There you go. There you go. Steady. Lameness and overgrown feet in general are a major problem to dairy cows. I doubt if you need me to tell you that. Not only is there the labour requirement of lifting the feet up and trimming them out, but affected cows also lose weight, milk yield falls, and in the more protracted cases, fertility is also affected. We mustn't, of course, forget the welfare of cows. Lameness is clearly a very, very painful condition, and that, I guess, is why cows lose weight. A proportion of cows, of course, never recover and have to be culled, often at the end of quite an expensive and protracted period of treatment, so there's additional costs there. The incidence of lameness also varies, as you can imagine, considerably from one farm to another, with figures for well-recorded herds varying from as low as 4% to as high as 55%. That's of cows treated per year. So, what can be done to treat this expensive and quite distressing condition as far as dairy cows are concerned? Well, that's the objective of this programme. What we hope to do is to look at the structure of the foot, the internal and the external structure, look at weight-bearing surfaces, what happens during overgrowth, and then demonstrate the principles and procedures of foot trimming. Well, it's not very easy to demonstrate the anatomy of the foot while we're stood here, so let's go off into the laboratory and examine some specimens that I've already got prepared for you. Right, here we are at the lab then. As you can see, there's a selection of some of my bits and pieces of feet, a fairly motley selection it is. Let's actually start with a whole foot, that's this one, and so we can see what the basic component parts of a foot are. The foot consists of 2 claws. The outer claw, or lateral claw, which is usually slightly larger in the hind foot, and the medial claw. Now, each claw itself has 3 component parts. There's the hoof, which is the structure we can see on the outside. And then inside of that, there's the corium, or the quick. That's the support structure, carries the blood vessels and nerves and so on. And then, right in the centre, we have the bone. Right, let's then look at the hoof to start with. The hoof consists of the wall running down over the outside here, and of course wall running down on the inside in between the claws. So the wall is there, and then we have the sole across the bottom of the foot there, and the sole there, and the heel. So these are the heels of the foot. The wall is an interesting structure because the wall is actually formed from the top of the foot here. So the wall is being formed at that point by a series of papillae. These are small projections, and they literally extrude tubes of horn which are moulded together at this point and then slowly pass down over the outside of the hoof. So there they are, slowly passing down over the outside. And when I say slowly, it is quite slow. It's approximately 5 millimetres per month. Now, the distance from here to here in an average foot, from the ground surface to the coronary band in an average foot, is 75 millimetres. So if we divide that by 5 millimetres per month, it means it takes 15 months for horn produced here to come into wear at the toe. And we can in fact see on this foot what some people call a hardship line. Do you notice this groove running here across the front of the hoof? Now clearly something went wrong and that there was an interruption of horn formation at that point. And we can work out when that occurred by taking a ruler and placing it across the front of the foot. And we can see that the distance from the hardship line to the coronet is approximately 50 millimetres, say, just slightly less. Let's say it's 50 millimetres. So 50 divided by 5, that means that that's 10 months ago that something went wrong with horn formation in this cow. It could be because of acute mastitis at the time of calving, particularly a really severe E. coli mastitis. Or maybe a uterine infection, a severe metritis, could also produce the problem. And even irregularities of feeding. The classic one would be to introduce a cow onto very, very high concentrate feeding immediately after calving with no slow build-up. Any number of factors, therefore, can produce these hardship grooves. The horn of the heel, this part here, is considerably softer than the horn of the wall. Look how easily it can be depressed by pressure with the thumb. Unfortunately, because it's softer, it's easily eroded, and that's one of the reasons why we get heel necrosis, of course. Now, the horn of the heel is produced by a specific band known as the periopal, and the horn itself is called perioplic horn. Not only does it cover the heel, running over this part, but it also covers the front of the wall, and it imparts the shiny, glistening appearance that we often see on the front of hooves. If the periopal becomes damaged, as it sometimes does under very dry, sandy conditions, then cracks start to appear on the hoof, and these are called sand cracks. You get a fissure developing down through the normal hard hoof, and some of them can actually get infection developing in them. The third part of the hoof is the sole, and the sole is the flat part here that covers the bottom of the hoof. And the sole is again produced by these papillae, these little finger-like projections that are extruding tubes of horn. And the horn here is, of course, growing from the corium of the sole downwards, down towards the bottom of the foot. So actually on the bottom of the foot, then we have 2 or even 3 structures. We have the heel, we have the wall running around the outside towards the toe and back to the first third of the axial cleft, and we have the sole. And where the sole joins the horn of the wall, then we have this structure known as the white line. And the white line runs from the heel around to the toe and back along the first third of the axial cleft. Right, let's go and get one of the other specimens. This one here I've actually prepared so that we can see the white line much more clearly. The white line runs from the heel forward around the outside of the foot, the abaxial surface, to the toe, and then back along the axial surface for the first approximately 1/3 of the interdigital cleft. You can see it again on the other claw, running from the heel forward to the toe and back to the first third. The white line is an extremely important structure, and you'll hear me talking about it quite a lot, both in terms of foot trimming and of many of the diseases that affect the foot. The second structure within the claw that I want to talk about is the corium, or the quick. This is the tissue which carries nerves, blood vessels, and of course the building materials to actually produce the wall. What I've done with this foot is I've sawn down through the front of the wall and actually sectioned through the foot so that we're now able to open the hoof like this and see the structures inside. The corium, or the quick, is the support tissue of the foot, and it's situated between the hoof, here's the hoof wall and the sole, and the pedal bone in the inside of the foot. So here's the corium running down here. You can see how it's quite soft and spongy, down towards the toe,